Well, good afternoon, everyone. Thank you for that introduction. I'm Chris Yoakum with Snowline, and we have Suri Zhang here. Can everybody hear me in the back? Well, today, I want to talk to you guys about our product, the Snowline. What we do is we design next-generation ice and snowpack removal systems, and our mission objective is to eliminate road chemicals and abrasives. We research, design, test, develop, and manufacture next-generation snowpack removal systems and methods. Our design considerations include eliminating environmental impact. We consider labor reduction and economical savings in our designs. Our intention is to reduce as much cost as possible and save the environment. So we want to completely eliminate salts from being used if possible. We have an improved efficiency method in our designs. We've neatly packed multiple operations into one packaging unit, as I will demonstrate to you in a few minutes. And we consider the preservation of the infrastructure in the design of our system. We currently have operating units in the US, China, Mongolia, and Canada. We'd like to take a moment to thank our collaborators, the University of Nevada, Reno, the California Department of Transportation, the University of Waterloo, Canada, Ministry of Transportation in Ontario, Canada, the China Highway and Transportation Society, and the Harbin Institute of Technology in China. Our collaborators were responsible for collecting data for research purposes and design purposes. So today I'm going to talk to you guys about winter road management, some of the hazards and the limitations of our current methods, what our solution is to, our answer to those limitations are, the economic environmental impact, the effect on the public, and introduce our product to you guys. I'm also going to discuss a little bit of our design and development today, what our working principles are behind our product, the ice breaking tooth design and how it's been optimized to remove ice and snowpack on the roadways. Talk to you guys about our testing and analysis methods, discuss a little bit about road formations, road condition formations, and what we considered in our testing. And then I'm going to conclude with some benefits and a summary of our future work. All right, so winter road management. I have a short little video here of a car pileup on I-94, a 193 car pileup in Michigan in January of 2015. It kind of demonstrates the extreme hazard presented by snow and ice on the roadways. So snowy, slushy, icy pavements have caused, current statistics indicate, over 1,300 deaths per year in the US and almost 117,000 people injured. That's pretty significant and definitely something that needs to be addressed. The drawbacks of these types of conditions are that the average highway speeds are reduced between 5 and 40% in heavy snowfall, and the speeds on arterial roads are reduced by 30 to 40% in snowy or slushy pavement. Over 70% of the nation's roads are located in snowy climates, and nearly 70% of the U.S. population lives in those snowy climates as well. 24% of weather-related vehicle crashes occur on winter roads. So the economic impact of impassable roads is very significant. In a study done by the American Highway Users Alliance and IHS Global Insight, indicated that between $300 and $700 million per day is lost per state for impassable roads. And this is due to a number of factors that are combined direct and indirect costs that include industry shutdowns and essential services such as transit and health services. And this actually, I want to discuss the essential services for just a moment. A disconnection of lifeline routes is a life or death situation, and it must be avoidable. That's a pretty big, it's life or death, so we have to address that. Additional factors include employee lost wages, lost tax revenues, retail trade, and changes in household spending due to changes in production. As a general rule, winter road maintenance allocation is approximately 20% of the Department of Transportation's maintenance budgets. Some of our current solutions, which are very good solutions, are the snowplow and snow melt. Those are primarily what we use for snow removal, snow and ice removal. The advantages of a snowplow is that it's good for bulk snow removal, but for light snow, right? So stuff that blows pretty easy. The compacted snow that California sees a lot in some of the other states is a little more difficult to remove. And in addition, the snowplow can't remove ice, and that requires an additional ice melt cost. It can't profile the road, so the contour of the road, there's still ice left on the sides of the road. In addition, the snow melt that's used, typically the most basic snow melt, loses its effectiveness at 15 degrees Fahrenheit, and it's very environmentally toxic. In fact, it's so toxic that, as an example, there were 6 people that died in a collapse in Toronto, Canada. The reason this is so significant is that there are 22 million tons of salt scattered annually in the US alone every year. So that's 44 billion pounds of salt. That's pretty significant. If you run the numbers and use the most basic salt cost at $65 per ton, that comes out to $1.43 billion a year in just salt materials alone. That doesn't include abrasives, fuel costs, operator costs, maintenance costs, and that's a very conservative number, being that it's the most basic of salts. Areas that are impacted by salt toxicity include soils, groundwater and surface waters, vegetation, aquatic and biota wildlife, traveling vehicles, and infrastructure. An example of this includes the Great Lakes, where residual snowmelt finds its way into the lake water, threatening aquatic life and polluting freshwater resources. In addition, one of the after effects, or the aftermath of the application of snowmelt is rust to passing vehicles. So as mentioned, 70% of the US drivers live in winter climate regions, and 15% of those drivers require yearly rust damage repairs to their vehicles, which totals about $3 billion a year, or $490 per vehicle. So to address some of these concerns, Snowline has developed a machine that is capable of removing both ice and snowpack in one package. And the objectives are to reduce and potentially eliminate environmentally toxic agents and to significantly decrease the cost of winter road management efforts. In a study done in China, we considered operator wages, fuel consumption, and equipment depreciation and converted that into American wages. And we get a cost of about 1/40th the current cost for applications of snowmelt. So as the snowmelt costs increase, the application of snowmelt costs increase, the cost of operating a snow line is decreasing. So this here is Mr. Xiaoshen Zhang. This is our inventor and owner of Snowline. After 30 years in highway road management, Mr. Zhang realized the immediate need to improve our current methods. This is a picture here of a test done in District 2 at Caltrans. You can see the snow line there on one of the front loaders that Caltrans employs. Our company mission is to keep winter roads safe for traveling vehicles and to reduce road chemicals and abrasives. We want to provide solutions for weather conditions ranging from light inclement weather to extreme conditions, and restore road friction to traveling vehicles in all weather conditions. We want to protect the environment, reduce the wear and tear on the vehicles and the infrastructure, and we want to decrease winter road maintenance costs. So to do that, I'm going to discuss the design and the development of the Snowline. You can see here, and I'll show you some videos and pictures here in a minute that demonstrate this a little bit more efficiently, that there are 3 primary functions to the Snowline. The very first one is the independently displaced ice-breaking wheels. So these wheels fragmentize ice and snowpack that's compacted by traveling vehicles. Once it's fragmentized, it's sent to a shovel system that's also independently displaced and suspended. The shovels collect the ice and snowpack and then send it into a hydraulically operated auger system that then translates the material laterally to the side of the road without any applications of snowmelt or abrasives. So here's a quick little video on how that functions. You'll notice in the video that it's able to contour the profile of the road. So these ice-breaking wheels dig into the thickness of the ice and snow compact. These teeth here have been specifically designed to keep wear and tear down on the road and to optimize the efficiency of the ice breaking process. Once it's fragmentized, the material is then collected by a series of independently suspended shovels and then sent into a hydraulically operated auger system that translates the material laterally to the side of the road, as shown here. And as you can see, just like the ice-breaking wheels, the shovels are also able to contour the profile of the road, keeping constant contact and allowing for the machine to overcome obstacles in the road. The engineered tooth design optimizes ice and snowpack removal rates. It's a high hard material that maximizes wear life. The tooth profile protects against road damage. If you look at the tip here, it does have curvature to it that keeps the road from being dug into. And there are replaceable tooth options that are available on some of our models as well. As discussed a little bit before, I have a shovel system back here that's independently displaced and it allows the shovels to contour the road and overcome the obstacles in the road. So you'll notice it doesn't show it here, but the ice-breaking wheels are up here in the front. So the ice-breaking wheels fragmentize the ice and snowpack and then are sent into the shovel system where it's conveyed up into the auger and then translated laterally. These shovels, a nice feature of this system is that the shovels retract when the vehicle is reversed. So it automatically retracts the shovels and you can now back up the vehicle without any concern of harming the system. Testing and analysis, I'd like to talk to you a little bit about how we tested our product and what we did to optimize its design. We have 4 primary testing considerations: ice and snowpack, pavement structure, various testing regions. We wanted to gather data from regions across the globe, and our operating speeds. We wanted to optimize the efficiency in the application of the Snowline. In the ice and snowpack considerations, we considered thickness, hardness, type, and the ratio of ice to snow. And in the pavement structure, we considered the profile of the road and the contour of the road, things that included bumps and holes and obstacles in the road as well. Various testing regions included China, US, and Canada, and it allowed us to collect samples that gave us population variety. So different types of snow and ice were collected as we traveled and tested the product. And as mentioned, the operating speed, we wanted to maximize our operating speed. So this is kind of a quick little guide on how the formation of road conditions occurs. Traveling vehicles create the ice and snowpack, but prior to that, there's 4 different methods for creating the road conditions. There's rain, freezing rain, sleet, and snow. What happens with rain is you have the frozen precipitation in the clouds that falls and hits a warm air pocket, and it is then melted, and it reaches the road as rain. In the freezing rain condition, you have frozen precipitation that hits a warm air pocket, it melts, and then hits the surface as rain, and is then refrozen into a sleet, causing slippery conditions. That's freezing rain. In the sleet condition, you have the same thing, but it freezes again before it hits the road. And then we have snow, which never actually hits a warm air pocket. This here is a demonstration of a test we did with Caltrans in District 2. So notice here that this is an already plowed surface. I'd like to point out towards the end of this video, you can see the contrast between the plowed surface and the road that was processed by the snow line. This is also the same model that you guys will see for those of you that are coming to the static display today after the presentation. You'll see this model and our new model that we're about to release. This is one of my favorite videos. This shows a close-up of the fragmentation process of the snow line. It's post-processing. But you can it really demonstrates how well it fragmentizes the ice and snowpack. And here at the end of the video, you'll see the contrast between the plowed surface and what was used by the snow line. The benefits of a snow line are that they provide sustainable winter operations. So this gives highway equipment managers dependable and repeatable road management methods. It's a one-time purchase, so there's no yearly cost associated with this method of snow and ice removal when compared to salt applications. There are wearable parts on the snow line, which is insignificant compared to the cost of snow melt as seen. It works just as well on asphalt as it does on concrete. It can be used in standard operating procedures and best management practices. It's environmentally friendly. It's 100% non-toxic to the environment. You introduce no toxicity. It enhances traveler safety. It's operable in weather conditions where meeting salt fails. It can be used in virtually all winter weather conditions, limited only by the extreme cold on hydraulic systems. It allows for the drop of chain control requirements much faster than current methods. It significantly reduces winter road maintenance costs, and it can be integrated with maintenance decision support systems. Currently, our future work is to integrate the snow line into a grader. Right now, I'm working with a team of engineers at the university. As Steve here mentioned, I'm a student at the University of Nevada, Reno, so I'm leading a team of 5 engineers to design the integration of this and the coupling system between that. We're also going to expand our scope to urban and city roadways. We're thinking about putting it on the front of regular plows. And then we want to produce models capable of eliminating black ice under 2 millimeters thick. Okay, so you are all invited to see our static display space where you can see the snow line in person. We also have a new facility in Reno that's open for tours at 1312 Capitol Boulevard. Siri here can get you guys some cards.
Is there a minimum thickness that your product now is capable of removing material down to? You talked about a 2 millimeter in the future.
Yep, yeah, so that's our current limits right now is about 2 millimeters, depending on the hardness of the snow and ice compact. So the real hard stuff is about 2 millimeters, where the softer ice and snow compact generally gets down to the surface. So.
The preceding video was produced by the National Center for Pavement Preservation. More information can be found at tsp2.org. That's tsp2.org. Additional support provided by Michigan State University.